ABCD is the cross section of a ABCDE is the cross section of a building. All the lengths are given in meters. Calculate DC. Okay, so this is the side which we need to calculate. Okay, if we look at the entire shape is definitely not a regular shape. It's an irregular pentagon. And if I consider the lower part of the diagram, that is BCDE, that is a trapezium. I can maybe calculate the length of CD using the area of trapezium formula only if I knew the area of the trapezium, which is definitely not there. So what am I going to do? If you figure out okay, what must be done to find out CD, then the question is very easy. The only thing that has to be figured out is what to do. There has to be some construction, some additional construction has to be done. After that has been figured out or after that has been done, the question becomes very easy. So what we have to do, we will join B to this side. We'll draw a perpendicular line from B on DE, something like this, okay? We'll draw a perpendicular line from point B to DE. And let's say that this point is F, okay? Just to make it easier for the reference. Now, BFE becomes a right angle triangle. This angle is 90 degrees. As I mentioned that I have drawn a perpendicular from B on DE. So BFE is a right angle triangle. And the length of BF is same as the length of CD. So if I somehow find out the length of BF, I'll be able to know what is the value of CD. So now instead of finding CD, I'll focus on finding out the length of BF. In triangle BFE, BE is the hypotenuse, which is 15.1. And EF becomes 2. How? If you look from E to D, the entire length is 6. And if you look at this length, this part is same as this BC. So I can say that this length over here is 4. Okay. If you subtract 4 from 6, then you are left with this part, which is going to be 2, right? So what is that we are trying to do is finding out the length of EF first of all. Once we have EF, then we'll be able to calculate FB, and then FB is same as the length of CD. So the first thing that I'll be performing, I have already done the construction. I've drawn the perpendicular from B on ED. Then I'll say that the length of EF is actually equals to EF. Okay, EF. Let me write it again in a clear way. Length of EF is equals to 6 minus 4, which is 2 meters. EF is 2 meters. Now that I have this length, I'll use Pythagoras theorem to find out the length of BF. According to Pythagoras theorem, hypotenuse square, which is 15.1, is equals to base square, which is for me is from F to B, plus 2 square, the length of the perpendicular. 15.1 square is equals to 228.01. This is 228.01 is equal to FB square plus 4. Then I'll remove this 4 and take it to the other side. This 4 is subtracting over here now. So that will be 224.01 is equal to FB square, and I'll take the square root on both the sides to get the value of FB. This is square to cancel with this one, and I'll take the square root of 224.01 is going to be 14.96. So we can say that FB is equal to 14.96 meter. And as I mentioned earlier, that DC is equals to FP. So DC is equal to 14.96 meter.